Today we are coming to treat the last rule of IP addressing. Next. So the last rule is the rule of subnetting. Variable length subnet mask. That is what we are going to treat today. Let's reflect on what we did the last time we met concerning subnetting. So if we have this scenario, supposing we have a class C of 192.168.30 and 0/24. And we've been asked to subnet this class C such that we can have 16 subnets. What is the approach? It's so simple. You know that to have these multiple subnets, you have to do some bit borrowing. You have to borrow bits. And how many bits do you borrow? You are not sure. This formula will guide us. 2 raised to the power n is equal to subnets, where n is the bits that you have to borrow. So 2n is equal to 16. We have to find what n is. So it's obvious that n in this case is 4.
Hello,
if
Nat.
n
Good morning.
is 4, then it means you have to borrow 4 bits. Borrowing 4 bits and adding it up to this /24 here will give you a new subnet mask of /28. So all the 16 multiple subnets that you're going to have, each one will be a /28. This is a classless subnet mask. And every classless subnet mask has a block size. So this /28 will have a block size or a magic number of, let me bring the table up here. 1, 2, 8, 64, 32, 15, 8, 4, 2, because we borrowed 4 bits, let's count 4 from here. 1, 2, 3, and 4. So this is the block size for /28. And /28 is in the 4th octet. So now we can write down our multiple subnets. For lack of space, let me write the first 5. The first subnet, just like the mother, but this time the subnet mask is a /28. The second subnet will be 192.168.30.16. We are adding this block size to the 4th octet. The third subnet will be 192.168.30 and 32 /28. All of them are /28. And the 4th one is 192.168.30.48. Okay, let's end here. So these are subnets, and inside the subnets you can have IP addresses. So the first valid IP for the first subnet will be 30.1, 30.2, on and on to 30.14. These are the valid IP addresses you can have. And a broadcast of 15. For this subnet, the first IP will be .33, 34, on and on and on, and 2.46. 47 will be the broadcast. Every last IP address before you move to the next subnet is a broadcast address. Now, there's one thing you have to realize here. For each subnet, we have equal number of IP addresses. So every subnet will give us 14 IPs. In this case, this subnet will also give us 14 IPs. 14 IPs and 14 IPs. So all the 16 subnets that we are looking for will give us equal length. We say equal length, in the sense that all of them have equal IP block. Now, translating this in real life is not practical. Why am I saying that? So if you have branch offices that have variable number of users, let's say this network for a branch office they only need 6 IP addresses or 6 users. There's a connection to another branch office. And for this branch office, they need 19 users or 19 IP addresses. The other branch office will need, let's say, 41 IPs. The rule 5 will not help us plan this network. It will be possible because the rule 5 only permits us to have equal number of IP addresses for each subnet. So how do we solve this problem? We are going to use the variable length subnet mask rule to solve it. And that is the rule 6. So let's use this topology to create a scenario here. You have a class C of 192.168.12.0/24. And you have this topology you are seeing on the board. This is one network where computers will be connected. And in this scenario, this is a branch office. Let's say tertiary branch of any company. Then this network will also come, a different branch office. And for them, they need only 19 users or 19 IP addresses. Then another branch office in a densely populated area where the staff are many. So they need 41 IP addresses or 41 users. Also note that from router A to router B is a point-to-point network. It's also a network or a subnet. But in this network, we need only 2 IP addresses, one to assign to this interface and another to assign to this interface of router B. So we only need 2 IP addresses or 2 users. Same applies to this point-to-point network from router B to router C. We need just 2 IP addresses, one for this interface of the router and another for this interface of the router. So 2 users. How do we plan for this network? We are going to use the variable length subnet mask rule.
Nat,
Yes.
you make I come in late.
Sorry?
You make her come in late.
Oh, you were waiting there. Sorry. Okay.
I started jam cry.
Because you didn't come early.
Oh, I did.
But we have not done anything yet. We just started with the rule 6. Okay. Okay. We have not started anything serious yet. All right. So, what does the rule 6 say? It's something you know already. Are we aware that the network bit plus the host bit will give us 32? Let's call this one equation 1. We are also aware that 2 raised to the power h minus 2 will give us the valid number of IP addresses, in this case, users. That is also equation 2. Then we also have to establish the fact that n, this n here you are seeing, is the same as the subnet mask. N is the same as the subnet mask because subnet mask is the number of network bits. Okay, so our first step here is to find the value of n for each network. In other words, we are finding the subnet mask for each network. That is the first step. And how do we do that? We'll pick equation 2 first. 2 raised to the power h minus 2 is equal to users. Then taking this first network, how many users do we have? 6. So we are going to substitute 6 in place of users. So we have 6. What are we doing? We are looking for a value for h. When we get that value for h, we come and replace it here to get a value for n. That's all. And we are going to do that for each subnet. It's as simple as that. So taking this first subnet, we are taking it subnet by subnet. 2 raised to the power h minus 2 is equal to 6. So let's group the like terms and unlike terms. 6, 2 causes the equal sign to be positive. So 2 raised to the power h is equal to 8. In this case, h will be 3 because 2 raised to the power 3 is 8. Once we have a value for h, we come to equation 1 here. Let's repeat it here. N plus h is equal to 32, equation 1. And we are going to substitute 3 here. So n plus 3 is equal to 32. N is equal to 32 minus 3, and n will be equal to 29. So our subnet mask for the 6 users is going to be /29. Is that difficult? Very, very easy steps. We do the same for the second subnet. For lack of space, let me delete this. I'm going to repeat the same steps. So for the 19 users, we repeat the equation 2 here. And we put 19 in place of the users. 2h, the 2 causes the equal sign here to be positive. So 2h is equal to 21. Now take note, this equal sign here is not a strict equal sign. Okay, because we don't want fractions for the h. It has to be an integer or a whole number. So we're going to do trial and error. 2 raised to the power 2 is equal to 4, which is less than 21. We move to the next integer. 2 raised to the power 3 is equal to 8, less than 21. We are not going to accept that. We move to the next integer. That is 4. So 2 raised to the power 4 is 16. It's also less than 21. We are not going to accept that. So the next available integer is 5. Even though 2 raised to the power 5 is going to give us 32, we will accept the 5. It's more than 21, but it's acceptable. In this case, h will be equal to 5. Once h is equal to 5, we are going to equation 1 to substitute 5 in place of h. So we have n plus 5 is equal to 32. Where n is equal to 32 minus 5. 5 will cross the equal sign to be a negative. N is equal to 27. So for the 19 users, our subnet mask has to be /27. Very, very easy step. Please, are you there?
Yes.
Nana,
Yes, we are here.
Please, I'm here.
How is it going? Is everything fine?
Yes, please.
Good.
For now.
Not.
I love that for now.
Hello, sir.
Yes?
Yeah, as she said, for now, meaning there's a question. Why we accepted 5, but rather not less than, because 32 is more than 21. That is almost like 1/3 of 20.
Yeah, that's why I'm saying that it's acceptable, because we don't want a fraction. If we have to be strict on the 21, then the h will be a fraction. And that is not acceptable. So we run it off. Okay?
Not.
But I'm coming. 2 raised to power 4, which is going to give us 16. Which is almost like 16 minus 21. Will give us 5 difference.
All right, listen. 2 raised to the power 8 will give you, 2 raised to the power 4 will give you 16.
16, yeah.
Correct?
Yeah, correct.
We're talking about 19 users. And we have 16.
Oh, okay.
So some people will not have IP address. Is it better to have a lesser IP or more IPs?
Oh, okay. It's better to have more IPs.
All right. And reserve some, because maybe your number of staff will even increase.
Oh, okay.
Okay.
Thank you very much.
Any other question, please?
Yeah, not. So is this rules 5 or 6?
This is rule 6. I've done rule 5 already.
Okay. So what exactly does this rule say?
That is it.
Just the equation.
Yes.
So what does it actually achieve? I'm trying to just understand.
It achieves variable length subnet mask. Okay, in a situation where you have varied number of users. That is why I started from the rule 5. With the rule 5, you are going to have equal number of users. Remember, if it's a /28, it will be /28 for all of them. /28 here for all of them. And that is not an ideal situation, because /28 will give us 14 IPs. So in that case, we are restricted. For every branch office, we're going to have 14 IPs. That will not help our situation, because over here we have 41 users.
Okay.
You understand? So this rule is the variable length subnet mask rule. Okay.
Okay.
All right.
Not.
Yes, ma'am.
So from this example, it means that one IP address can actually have different subnet mask for different locations.
IP address.
Yes. And or one like the 192.168 dot, let's say 12.0.
192.168.
Like what you have there.
Like
what you have up there, yes.
Yeah.
Let's say a company goes in for this IP block.
Yeah.
The /24. From this particular example, where you have different branches, can you use the VLSM to apply here?
Yes, that's what we are doing.
Okay, so like I want the confirmation, like this one IP block can
Yes.
be
So we are
can be
using
taken
this
through these
one
steps.
IP block to
Okay.
subnet variably.
Okay.
Okay.
So in this case, because of
Please, should I come
the
in?
number of users, you can actually quote unquote ignore the /24.
Oh no,
And
you are not going to ignore anything. You let's land. Maybe your question will be answered. Okay. Let's land. Maybe your
Please, should I
question.
come in?
Yes, Thomas, come in.
Yeah, please. From what I'm seeing with your examples, right, it means that with the VLC, it allows you to use different subnet masks across a network, right?
Sure, that's it. That's
Okay,
it.
thanks.
And that is, in most cases, that's the real life situation. If you are to subnet for your branch offices, you don't expect every branch office to have the same number of IP addresses. It doesn't work that way. Imagine you have a branch in a place like Tudu, that is a densely populated area. So you require a staff strength that is more than a branch office in a place like Domiabra, a village in the Domiabra region, where you only need maybe 3 staff. In that case, you need just 3 IP addresses or slightly above 3 IPs. That is a real life scenario. So variable length subnet mask is very important. Okay. All right, so let's go to the 41 users. So for the 41 users, 2 raised to the power 2 is equal to 41. We are looking for h. After that, we will place h here to get n. So 2 raised to the power h is equal to 41 plus 2, because 2 goes there to add up. And that will
43.
give us
43.
43. All right, thank you.
Yes, sir.
So let's do our try and error. This time, let's start from 2 raised to the power 5, because we already know that 2 raised to the power 5 is equal to 32, less than 43. So we will accept that. We go to the next integer, 2 raised to the power 6 is 64. We accept it. So our h will be 6.
6.
Post bit is 6. If h is equal to 6, or host bit is equal to 6, bringing down equation 1, what will be n?
26.
So n will be 32 and not 6, and n will be 26. So for the 41 users, our subnet mask will be /26. What about the 2 users? Okay, so for the 2 users, 2 raised to the power h minus 2 is equal to 2. 2 raised to the power h is equal to 2 plus 2. 2 raised to the power h is equal to 4. H will be 2, because 2 raised to the power 2 will give us 4. So if h is 2, network bits plus host bits should give us 32. So network bits is equal to 32 and 2, which is equal to 30. So for the 2 users, we are going to have /30 for both of them. This is the first step. This is the first step. So anytime you are given a variable length subnet mask scenario, use the above equation to get the subnet mask for all the subnets. That's the first step. Then what is the next step? The next step, we are going to write all these subnet marks in descending order, the highest first. So /30 is the highest. We bring it here, underline it nicely, followed by /29, underline it nicely, followed by /27, descending order, then /26. Now these are classless subnet masks, all of them. In this case, they will all have block sizes. All of them will have block sizes. So what's the block size for 30? Let's write their block sizes by them. So in 30, we borrowed how many bits? Suppose we are subnetting from /24. Okay, supposing we are subnetting from obviously we are subnetting from /24. That's our case up here. So for the 30, you have to borrow 6 bits.
6.
1, 2, 3, 4, 5, 6. So our block size is 4. For the 30 users, our block size is 4. What about the 29 users? How many bits did we borrow from /24?
5.
5.
5.
So counting 5, 1, 2, 3, 4, 5. Our block size is 8. /27. How many bits did we borrow from /24? 3. So 1, 2, and 3. 32.
3.
And for the /26, we borrowed 2 bits. So 1, 2. Our block size is 64. All right, so first step, get the subnet marks for all of them. And once you get the subnet marks, obviously they are going to be variable length subnet masks. Then you have to write their block sizes by their size. So for the /30, we are going to write down the possible subnets. So assuming we are using this /30 to subnet this IP 168.12.0.24. Here's our IP here. Assuming we are using /30 to subnet this, and we have a block size of 4, so our first valid subnet will be just like the mother, 192.168.12.0. The next subnet will be 192.168.12.4. We are adding the block sizes, the one we did in Group 5. So you just write down the possible subnets, 12.8. Okay, we are adding the block size to the last octet, 192.168.12.12. 192.168.12.60. These are all possible subnets that a /30 can have when you are using this class C. What about the /29? The first valid subnet always looks like the MAM, 192.168.12.0. And the subsequent subnets are going to be subnets which will be addition of 8 in the 4th octet because the block size is 8. So 192.168.12.8, 192.168.12.16, And all these subnets here are /29. I didn't want to do it that way. That's why I brought the /29 up. Okay, all of them have /29. Same applies to all these subnets here. They are all /30s. 192.168.12.24. All of them are /29. Now let's come to the /27. We are writing down all the possible subnets. So 192.168.12.0. The second subnet will be additions of the block size, which is 32. Sorry, 32.